reflection, congruence, and rotation. Symmetry. An object that can be divided into two or more halves of same shape and size is said to have symmetry, or is symmetrical. The line that divides the object into equal parts is said to be a line of symmetry. An isosceles triangle below has one line of symmetry. A right-angled triangle has no symmetry. A rectangle has two lines of symmetry. Each part of a symmetrical figure is a mirror image of the other. Reflection. Reflection of objects is a form of transformation. A transformation is said to be a change in the position or dimension of a shape or both. Properties of reflection. The object and its image have the same size and shape. A point on the object and a corresponding point on the image are equidistant from the mirror line. The image is laterally inverted, that is, left appears as right and vice versa. A line joining a point and its image is perpendicular to the mirror line. A point on the mirror line is an image of itself. Reflection in the Cartesian plane. To reflect a figure, we construct a perpendicular from the line to the mirror line. The image of the reflected point, usually the vertices, must be equidistant from the mirror line as the object. For example, reflect the triangle ABC on the line y is equal to 0 and reflect the image A', B', C' on the line y is equal to x. So I want to reflect the triangle ABC twice, and the first mirror line is the line y is equal to 0. The line y is equal to 0 is the x-axis. So to reflect that triangle, the first thing I'm going to do is that I will drop a perpendicular from A to the first mirror line, that is the line y is equal to 0. Now I'll then take the distance from A to the mirror line and then take the same distance from the mirror line on the opposite side along the line that I produced, and then I have my A'. I'll then repeat that for B, and I have my B'. Finally, I repeat that for C, and I have my C'. So I have my new points A', B', C'. The only thing I'm going to do now is to join the points, and now I have the image of triangle ABC reflected on the line y is equal to 0, or the x-axis. Now the next reflection is reflection on the line y is equal to x. The line y is equal to x is this one. Now I'll repeat the same procedure. I drop a perpendicular from A' to the mirror line. The line y is equal to x. So there is my perpendicular, and then I take the distance from A' to the mirror line. Take that same distance along the produced line on the opposite side of the mirror line, and I will have my A'. I then repeat for B prime, and I will have my B prime prime. Finally, I do that for C. I do that for C prime, and I will have my C prime prime. So there I have my new points: A prime prime, B prime prime, and C prime prime. Now I can join the 3 points to complete the triangle. So there I have my triangle ABC reflected twice. First on the line y is equal to 0, and then on the line y is equal to x. Congruence. In our previous example, triangle ABC underwent 2 successive reflections on the mirror lines y is equal to 0 and y is equal to x. The following can be deduced. The length of the line segments doesn't change. The angles remain unchanged, and the size and shape remain unchanged as well. We say that the object and its image are congruent. 2 shapes are congruent if they have the same size and shape. If 2 congruent shapes are slid and fit on each other exactly without turning over, the congruence is direct. For example, triangle ABC is directly congruent to triangle PQR. If congruent shapes have to be turned over to fit, the congruence is said to be opposite. For example, triangle ABC below is opposite congruent to PQR. Testing for congruence in triangles. For congruent triangles, the naming must be corresponding. That is, if triangle ABC is congruent to triangle PQR, then the side AB corresponds to PQ, BC corresponds to QR, and AC corresponds to PR. Angle ABC corresponds to angle PQR, and so forth and so forth. Conditions for congruency of triangles. The 3 sides of one triangle are equal to the corresponding sides of the other triangle, abbreviated SSS, as shown below. Two sides and the included angle of one triangle are equal to the corresponding sides and the angle of the other, abbreviated SAS, as shown below. Finally, 2 angles and a side of one triangle are equal to the corresponding angles and a side of the other triangle, abbreviated AAS or ASA, as shown below. Or a right angle, hypotenuse, and one side of one triangle is equal to corresponding sides of the other triangle, abbreviated RHS, shown below. Rotation. If a figure can fit into itself when rotated, it is said to have rotational symmetry. The number of times a figure fits into itself in one complete rotation is called the order of rotation. A rectangle has order of rotation of 2, a square order 4. A circle has an infinite number of orders of rotation. A square pyramid has an order of rotation of 4, and a circular cone has an order of rotation infinite. Rotation as a transformation. Rotation is a form of transformation whereby a figure is moved from its original position through a given angle about a fixed point. The fixed point is called the center of rotation, and the angle through which it is rotated is called the angle of rotation. The direction of rotation is important. A positive rotation is in the anti-clockwise direction. A negative rotation is in the clockwise direction. Thus, an anti-clockwise turn through 90 degrees is called a rotation of plus 90, while a clockwise turn through 90 is called a rotation of negative 90. Properties of rotation. All points on the object turn through the same angle in the same direction. The angle between a line and its image equals the angle of rotation. Each point and its image are the same distance from the center of rotation. The center of rotation is invariant, that is, it doesn't change. Note that a rotation is fully defined when the center and angle of rotation are specified. A positive rotation through an angle theta is similar to a negative rotation through an angle of 360 minus theta. Under rotation, an object and its image are directly congruent. An example: rotate the figure below through positive 90 about the center of rotation O. We follow the following steps. Join point A to O. At O, construct or measure 90 degrees anti-clockwise and draw the line from O. Measure OA. Take the same distance along the new line. This is A prime. That is, OA is equal to OA prime. Repeat the same with B and C. Then join the points A prime, B prime, C prime. Locating the center of rotation and angle of rotation. Triangle ABC is rotated through angle theta to triangle A prime, B prime, C prime. Let's try and locate the center of rotation and the size of theta. We follow the following steps. Join A to A prime, that is the broken line. Construct a bisector of A prime, marked line 1. Repeat the same with B and B prime, marking line 2. The point of intersection of the bisectors is the center of rotation, O. To get the angle of rotation, join C to O. Measure the angle COC prime. All bisectors pass through O. Two mediators are sufficient, and theta is the angle of rotation.
If you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor. It applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs. And once it starts going downhill, you're in trouble.